Okay.
Wait, what?
Yeah.
It looks like a VGA, but
It's a VG. No, is it a VGA?
it can't be VGA because that's for it's audio. You have to. I'll talk to you later about it. You said it's a
Okay.
speaker?
Yeah, hold on. It's a sound bar, which is really weird.
It
And
might
then
be VGA, but I don't think so.
it's
It's a
got
DVI. It's a
No, it's
DVI
not
cable.
DVI. DVI is a longer
the
one. What the
other
other stuff?
it's like super old, so I'm probably gonna I was gonna upgrade it anyway.
It is
But
VGA.
for right now
Yeah.
I've just been using my headphones whenever I
Yeah, I can help you with that after class. But all right, so you should have the stream should be up now. Um,
done.
It
so
says it's not working for me.
it might take you like another 4 minutes before you get the video feed.
No, actually, I'm on my computer today.
Alyssa, count to 20 and then maybe he's there.
Chris, did you delete your
Okay, I got it.
pictures? Asshole.
Oh.
No, it's still there. Wait, oh, yeah, he did. that's the
Put the picture back.
I've been peer pressured.
Put the picture back.
Okay, let me see it.
Echo.
That's because you
What the
have
fuck?
the stream going.
Oh yeah.
Evan,
Okay.
we are streaming. Please watch your language.
Oh.
Oh, we're streaming.
Don't
Okay.
don't make me write you up, please.
Oh, we're streaming.
Stream. Twitch just started talking to me, and I don't know what it was saying.
I heard an echo and I thought that he had
Bro, let me find it. I can't.
Chris,
I can't find it.
why did you take it down?
I've been. Hunter told me to.
No.
Yes, yes, you did. Wait, hold up. I might find it. Let me look at my screenshot. Let me look at the screenshot.
O'Donnell, what's your name on Twitch?
The Odon.
The Odon. Dude, look at my personality.
You don't
did
have
not
one?
Say that, or I did not hear
Oh,
you.
You just need the
bro.
picture that Chris had of the problem.
Last one.
Yeah, I'm pulling
not
up the
an internal
video.
force.
Oh, I got it. I
I
got
have
it.
it.
I got it.
I have it. I have it.
I already pulled up the video. Y'all are slow.
I
Okay.
already sent it to you.
So
whatever.
I'm not going to redraw the picture because that's going to take up a lot of space, and we are going to need space to do calculations and stuff. So you should already have it written down.
I'm on the Twitch now. I don't know where my pencil is.
Okay, so hold on. Let's see how far behind Alyssa is. So I'm going to count. You tell me when you see my fingers, Alyssa.
You should have just like not gone up there at all. 3, 2,
Yes. Specifically, I was.
4,
I
Three,
see your fingers now.
two.
What the heck?
1, 0.
1, 0.
Y'all are all off. This is weird. Y'all need to get some better internet.
Can has arrived.
I'm
Twitch has
I'm using a
delay.
hotel internet. Everyone's using it. What do you
No,
want
I'm
me to
talking
do?
about Hipskind and Kenna. And then Alyssa, because she
plugged
still
in
hasn't said anything
internet.
yet.
I know, but like,
should have just like not gone to the camera.
That would have been really good.
I'm on my computer today. I could not be behind.
Have you seen my fingers counting yet, Alyssa?
I don't know. I wasn't looking.
Oh, Jesus.
I can't see you.
All right, Alyssa, tell me if you see my
It's
fingers.
a brand new setup. It should for real be like working.
I can't see you, Mr. O'Donnell.
5,
Ugh.
4,
That's a yes.
3.
what the heck, Connor?
Dang it! I'm sorry.
4, 3, 2, 1.
1.
0.
4,
I got
Five.
the
You say
Four,
5.
3,
2,
1.
1, 0. Me and Michael.
Yeah, some of y'all need some better internets.
4,
I can't do
3,
anything about
2,
it.
At least mine's working.
1,
Okay.
0.
I mean,
has arrived.
as long as you're within like 10 seconds, it's not the end of the world. But you were like way off the other day. Okay. So you
It's
should
like the normal
have
Twitch delay.
the picture drawn in your notes already. And everything I did on the board on Friday, you should already have that. So I'm going to jump to the last step and just start working down from there. So we have our forces in all the directions. So when we sum up the forces on that, we get, do we want left to be positive or right to be positive?
Right.
Okay, so we had
Right.
FG2, no, there was no FG2. It was FG3X plus, what, F1 plus FF2 plus FF3 minus FG1X equals the MA, if I remember that correctly off the top of my head. FF1, FF2, FF3, and FG3. Yep, okay. So now the
See, I got
question.
that part right, but I don't know what to do from there. Sorry.
Okay, so you're fine. These two, the FG3x and FG1x, are super easily calculable. Remember, force of gravity is just mg, and since we're on an inclined plane, it will be mg sine theta. So this is what, 60? So this one will be 60 times 10 times sine of, what's that angle, 60. And this one will be, oh no, I have that backwards. This is the 45 one, my bad. So 45 sine
My
and
computer has a scientific picture that we're on a graphic.
you can download a graphing one. I sent you the link. If I need to send it out again, I can.
Oh, is it on Remind?
Yes. I'm pretty sure I sent it to physics as well. If not, I'll send it out.
Did you?
This sucks.
Is there a way to get like classroom, or not classroom, but like Remind on desktop?
Yeah,
Yeah, it's a website.
it's just a website.
It's a website. Okay.
Yeah, and it'll send you like notifications and stuff in
Oh,
like
is
the
it
bottom right corner and stuff.
The 90-day trial.
No, just go to remind. That yes, it's a. I think it's more than 90. It just says 90, but yeah, you should be able to. Okay, so this is what we have filled in. We don't know FF1, FF2, or FF3. However, we can figure out what the maximum values of all of these are, and if it's going to overcome the counteraction of these two. So those I'll have to do on the calculator because I don't know them off the top of my head. Because they're not going to be pretty, they're going to be nasty decimals. So 400, I'm in degrees, okay, sine of 45 minus 600 sine of 60. Okay, so I get that is 236.77. So once you combine those two on your calculator, FF2, that's what, 236.77. Okay, so again, I just put those in calculator, combine and get that. So the question is, are those three forces of friction enough to stop it from moving? So combined, do they have 236 newtons of force or more? So we got to figure out what their maximum values are. So that's how we figured this out. So if like they can all have a value of like 100, then obviously this could be up to 300. 300 is more than 236. Done. If they only have a maximum value of, let's say, 200, then they're not enough to stop. Then we would have an acceleration. So the first thing we need to figure out is what is the FF1 max, the FF2 max,
Wait, Mr. Dom.
and the FF3 max. What?
I got a different number than you.
Well, you're
Oh,
wrong.
no, she's right. I typed in 400, not 450.
Oh.
So, is it supposed to be negative 201 point whatever?
201.42.
Yeah.
Thank you for checking that. And whoever's chewing ice, mute your mic.
Evan. Dang it.
It's not me.
It was me.
Oh.
Okay, so thank you for catching that, kind of.
You're
42, not 47. 42. Okay. Still same setup though. We still figure out the max forces. So if I look at the force of friction on one, remember from yesterday, how do we calculate or Friday? How do we calculate the maximum force of friction?
The S.
MSFN.
So mu s Fn. So it'll be mu s, which I gave you was what, 0.15, right?
Yeah.
Did you give it to us?
Yeah, I
Yeah.
gave you mu s and mu k. Mu s
Wait,
Fn1.
I keep getting a different number than 201. I'm so confused.
Are you
'cause I
in
keep
radians?
typing it in.
Degree.
Oh, wait, hold on.
You're probably in radians from calculus.
I am.
Yep. Okay.
That makes more sense.
So we check out their maximum values, which is mu s times its normal force. Notice again they have Fn1, Fn2, Fn3, etc. And again, reminders for Fn1 and Fn3, they're on an inclined plane. So again, we have a formula for that. That is the mg cosine theta. And object 2 is not on an incline, so it's just mg. So this will be 0.15. Fn here will be mg. So object 1 was the 60. So 60 times 10, cosine of that one was 60 degrees. This one will just be the 0.15. I think it was what, 35, wasn't it? Kilograms, the top object.
Oh yeah.
So 35 times 10 for that one. And this one was the 45 times 10. So we should figure out what those three maximum forces of friction are, and if they're enough to stop the 201 number. So let's see, 0.15 times 60 times.
Wait, I have a quick question.
Go ahead.
Why is the F2 only times 10?
It's not on an inclined plane.
Oh, okay.
So that one's just mg. If you want to put it with an angle, you can, but the angle would be cosine of 0, because it's 0 degree, and cosine of 0 is 1, so you don't need it.
Okay.
Wait, why is it cosine instead of sine? Sorry.
Because it's the normal force. Remember, sine is the force down the plane. Cosine is the force into the plane. And remember, normal force is the one that's stopping that, so that's why we use the cosine.
Okay, that makes sense.
Actually, so this will end up moving, maybe? It's going to be, ooh, this is going to be close. Wow.
What?
Oh, no, right, it's not even close. It's 150. So it will be moving. I was wrong. So it does end up moving. So I got 45 for this value,
Okay.
52.5 for this one, and then 47.73 for this one.
Yes.
Okay.
So those are, I mean, pretty basic calculations, no big deal. So if those are the maximum amount of frictional forces, 45 plus 52 plus 47 is just over 150-ish. 150-ish is not enough to stop 201. So is the static friction enough to beat out the force that's being exerted on the objects? No, it is not. So therefore, friction is not enough to stop these objects. So will I use these numbers at all for anything? No, why not?
Because they're too small.
It's static.
So these are all static values, and I need to be using
Kinetic.
kinetic friction. So those numbers are all useless at this point. They're just used to figure out, is it moving or not?
I have a
It
quick
is.
question.
Go ahead, Kenna.
So for the... Oh wait, let's get to that and then I'll ask.
Okay, so I'm gonna keep going for now.
Yeah.
Okay, so all of these are useless. However, all I need to change is this mu s's to mu k's and get rid of this word max. And I'm good. And I can change all these to zeros. So obviously it's much harder for you to do because you've written them down. And you should show that work out. It's not like you should just erase it and then do this work. You should show that as part of your ideas and calculations. Realistically, I probably would have just done it on the calculator personally and figured out that it was kinetic and not static. Stop posting things in Discord. You're working.
Thank you.
Not funny. So
But it's Homer.
I don't care. You need to be doing this stuff. So we just need to figure out what those values are. So all we got to do really is go back and change the 0.15s to 0.10s on all of those calculations you've already done in your calculator. And then hit enter. So it's really not that bad. It's a pretty straightforward.
Bold of you to say.
So the normal force would be the same. Still,
Normal
right?
forces don't change, correct. So I get 30, 35. That's a terrible five. And 31.82. Okay. Relatively easy calculations. Again, you've already done these once in your calculator, so all you had to do is go back up and change the 0.15 to a 0.1 and be done with it.
For a second, I forgot what
Okay. So at this point, we just take these three, plug them in here, plug in our mass, and find your acceleration. So you get FF1. So 30 plus 35 plus 31.82 minus 201.42. The mass was what, 140 when we put it all together?
Yeah.
So equals
So why did we switch
140.
the 0.15 into 0.1?
Because we realized that static friction was not enough to stop the 201, which is the gravitational force being exerted on the objects. So if static friction is not enough to stop it, then it turns into kinetic friction. If static friction would have been high enough to stop it from moving, it would not have been moving, and we would have left it there. It would have had an acceleration of 0. However, since our frictional forces were not enough to stop it, then we need to move on to kinetic friction and change those values to kinetic values.
3 decimal places?
2 or 3 is fine, not really a big deal. And then you have a really easy equation there that you can, I'm going to assume, solve. So 30 plus 35 plus 31 point. I get an acceleration of 0.747. When you solve that basic algebra equation?
The negative?
Negatives all relevant to the box. So if it's, what is the box one, what does that mean box 1 is going to do? Which way is it going to accelerate?
I don't know.
That's what you have to answer. That's the question. So the value is 0.747. You wanted to tell me it's negative. What does that negative mean?
I don't know. I just got a negative when I plugged in the thing.
And that's fine, but you have to then tell me what that negative means. It's a directionality thing. Because each box,
Would negative...
a negative is going to mean a different thing for each box.
Okay, so wouldn't negative mean it's going to the left?
Well, not all the boxes are going just to the left. They have ups and downs and lefts and rights and all kinds of different things you could be. So you'll have to specify for each box.
Okay. Yeah, I can't.
So your left, box 1 will be going down and left. Box 2 will be going just to the left. And box 3 will be going up and to the left.
Okay.
So just having, when we talk about finding the acceleration of the boxes, because they're all tied together and going in different ways, if it was like a flat plane, yes, you could say it's just left. But because you have different directions, up, down, left, right, etc., you just look for the number and then tell me what each box will be doing if they were asking for a specific. Usually what they do is they ask you for the value of the acceleration on a connected system like this. So if you put negative or positive, it's not going to matter.
Oh, okay.
Okay, any other questions?
No. This? Okay.
Okay. Any other types of
epic.
force problems that you people want to ask?
No, but I'd love to know who Epic Awesome Bro is.
Jackson, how do you not know that? Remember I took away the
No, I
epic
got
awesome
that.
part of his name? He's just bro now.
Wait, what is it?
But why is he on the ACE Physics thing?
I don't know why he would be on the ACE Physics thing. Is he on the ACE Physics thing?
Yeah, he's on the Twitch. He put
Oh,
something.
why?
That's why I asked. Is it actually him?
Contact force, we add like the masses together, right? If they're going in the same direction.
Okay, sorry, say that one more time, Damien. You said something about contact forces.
Contact forces.
What about them?
If they're going in the same direction and have the same force pushed on them, we just add the masses together.
I don't think I understand your question. Contact forces technically have to go in opposite directions.
Could we go over like a contact force well?
Yeah, it's just like gravity and normal force. Gravity pushes down, normal force pushes up. And as long as you're not like falling into the table or something like that, or breaking the ground or something, then they are equal and opposite.
And what about between blocks? Contact force between blocks?
Well, in that case, they won't be opposites. They won't be equal, but they will be opposites. By opposite, we mean direction. So, like for instance, if I push on block one and block one's pushing on block two is then pushing back on block one. Now, at that point, they can have different values because there is an acceleration in that direction. So the difference here being, if you sit like a block on a table or something like that, then it's not going anywhere. So acceleration equals 0, down force equals up force. Instead, if you have like,
Chat is great.
so instead if you have like 2 blocks, this should be popping up about now.
Nope.
Ish. Instead, if you have 2 blocks pushing in a direction of motion, then at that point you will have an overall acceleration. So you have an A value. So that's the difference there. So the reason that they are equal and opposite on things like gravity is because they are, the acceleration is 0. So the sum of the forces equals 0. So they are equal and in opposite directions in order to cancel out. If the acceleration is not equal to 0, so it's some number, then at that point, one of the forces has to be bigger than the other one in order for it to have an acceleration value. If they were equal and opposite, there would be no acceleration. But if they're accelerating, then there's some value that wins there.
Yeah, one force is greater than the other.
Right, and that's just equal to the sum of the forces equals ma type thing. So for instance, this is actually a simplified picture of what we would look at with, like, let's say we have 2 blocks connected by a string and I'm pulling them. Well, I could then internalize that tension force just like we have been, and we get the picture above. And it doesn't matter if I'm pulling to the right or pushing to the right or whatever, it's just that force to the right is going to be the win. So like if I call this like block 1 and block 2, and this block 1 and block 2. So for this case, we have block, so we can kind of do the free body diagrams and just look at the differences between them, because they're pretty much identical. So if this is block 1 and block 2, block 1. At the top, you have the force obviously down of gravity, up of normal force. They cancel each other out. They're contact forces. The normal force is the contact force. You have on block 1, you have the force from block 2 pushing on it. And then you have some applied force to the right. However, for block 2, you have some force from block 1 to the right, Fg, and then Fn. 1, 1, 2, 2. When we go down here to where we have the tension, it's going to be a very similar concept, except for we're going to have tension forces acting on them instead of like force of block 1, force of block 2 type idea. So 1 will have Fg1 down, Fn1 up, Ft, Ft. This will have the force applied because I'm pulling in this case instead of pushing, because it's connected by a string, so I have to be pulling. And then Fn2 and Fg2. Now, as long as this force applied is the same force, these two situations will end up becoming identical. They'll have the same exact acceleration, doesn't matter if they're touching or not, or I could be pushing them to where they have a contact force between the two. Same situation, just different way of representing it.
Okay, essentially the same.
And the difference here on the top one being that you have these contact forces. 1 is pushing on 2, which is causing 2 to move. Because technically, if you're pushing block 1, you're not doing anything to block 2. Block 1 is doing something to block 2. Technically, that is correct. So like if I were to throw a marker at your head, I didn't do anything. The marker hit you. And it's always my fun thing. If I was to, say, hit your face would actually be hitting my hand as well. So you assaulted me back.
Then there's a lawsuit against them.
Exactly. See, and they cancel each other out. Therefore, nothing happens. However, no, it
Here you
doesn't.
break my hand. head when I punched you.
Right? Okay, does that make sense, Damien?
The thick skull. Yes.
Okay. Evan, chewing ice.
Oh, I made myself sorry.
All right. Any other questions as far as forces go? Want me to do any other types of problems or anything?
I like the name of the stream.
Failing at forces?
Yeah.
Yeah.
Dante has been quiet.
Oh, Dante's here? I didn't even know he came in.
Oh. He's muted.
That's fine. I just didn't know he came in. I didn't know some login Discord.
Speak,
Are we
boy.
do we have where okay, do we have a website where we can like find past papers if we want to work some out by ourselves?
I can give them to you, and I'm going to start giving them to you here as soon as we get done with the quote-unquote review over any topics you guys have questions on.
Oh, okay. I was just gonna go do some force problems, but okay.
Recovering from what?
I didn't say. Oh, poor man. Poor man.
I was waiting for you to say off stage. I'm recovering from off stage.
I feel like there's a pun on that, but I can't think of one.
No, there's not, Chris. Be quiet. Shit. So, any other questions on forces, or I guess pick the next topic if we have. Well, no, that's what I'm saying. I guess if we're done with forces, we can pick the next topic of review.
Remember how we did elasticity and like things bump into each other and stuff?
You mean like springs?
Yeah.
Because elasticity is springs bumping into each other's momentum. So I don't think we really ever combined.
Well, not together, but.
That's what I'm saying. Like, so I'm trying to figure out what your question, like, what topic you want me to cover is. That's why I'm.
Didn't you like imperfect and perfect elasticity when two things like collide, whether they keep going into each other or they bounce off each other? And stuff like
You're talking about elastic collisions. Is what you're talking about. There we go. Okay, so that's just collisions. When you talk about elasticity, you're talking about like springs and deforming and stretching things and squishing things.
Okay. Well, then the third one.
The momentum. Okay. I mean.
Yeah.
Yeah. I mean, we have collisions, so. Oh, 5 kilogram. Sure, we got that. We can start basic momentum problem. So you got a 5 kilogram object moving at 30 meters a second, traveling towards an 8 kilogram object. You've got a perfectly inelastic collision. What happens? So you guys should have a definition written down somewhere of what perfectly inelastic is.
They bounce. No, they don't. They don't.
Bounce.
They stick together. Sorry.
So perfectly inelastic, they stick together. So that will give us a picture that looks like this. And so 5 kilogram and 8 kilograms. Terrible 8. So 5 kilogram, 8 kilogram sticks together, and then you would look for what is their new velocity.
Final velocity.
VF. Yeah. At that point, we would use our momentum equations, which hopefully everybody remembers is
velocity times mass.
So momentum is equal to mass times velocity, but we also have to remember that P initial equals P final. So initial momentum is just a combination of momentums. Obviously, the 8 kilogram being stationary has none.
So 150.
So you get 5 times 30 has to equal 13 times VF. So VF is 150 over 13. That's a terrible 13.
11.54. That's rounded slightly.
Which is approximately 11.54. That works. And we don't really have a unit, so it's kilograms times meters per second. Terrible unit, but whatever.
Ew, momentum so ugly.
Oh, just like your face. I don't know. Is he still on the stream?
Wait. Jackson?
Oh, I don't know if he still is.
Why is the
I told him it was for AICE physics, not mechanics. So.
Why is it Twitch chat only an emo chat?
Because somebody decided to join a couple like last week or so and type not so nice things, so I changed it to emote
Oh, was
only.
it someone, like,
Wait,
not in
who
class,
did?
or someone, like, not in class?
I know exactly who it was now, so it doesn't matter.
Was it Alan?
No, Alan didn't type anything. I just banned him before he could he could do anything.
Alan just did emotes, didn't he? He took a picture of it and sent it to the Trek group chat, and he was like, "What the heck? O'Donnell banned me."
So there was no reason for him to be there, so I banned him.
No.
Okay, so there's your
You
momentum.
need access to that.
At that
Well,
point, you just really need to know what your different types of collisions are. So you have your elastic collisions, your inelastic collisions, and your perfectly inelastic collisions. You should know what all of them are by just definition.
wait, we should know what which is.
Elastic, inelastic, and purely inelastic, or perfectly inelastic, whatever you want to call it.
Perfectly inelastic is when they stick.
Yep.
Purely or inelastic. Wait. If perfectly inelastic is that they stick together, which is just inelastic. Is it that they continue in the same direction? And then is elastic that they bounce off?
Oh, if only we had a formula and definition sheet that we were supposed to have this written down on.
What was that you wanted? Sorry.
Elastic, perfectly inelastic, and then elastic.
He's back.
Okay, elastic is where the energy is conserved. Inelastic is where the energy is not conserved. I don't know. That's all I have.
Trying to be funny, I left and rejoined and it broke my audio.
Good job. And you're right, Kenna.
Okay.
So elastic collisions, again, if you don't have this stuff written down as we're going through it, you should have a page of where you're writing things down. Your elastic...
If you wrote it down on, like, our computer.
I don't care where you write it down, as long as you have it. So elastic, the energy is conserved, and by energy we're talking about kinetic energy. Inelastic energy is not conserved, so you can only use the conservation of momentum. And then with perfectly inelastic, obviously energy is not conserved, as well as the objects stick together. Does that answer your questions on collisions, Dante?
What about if they were colliding but on a surface that had friction? No.
What you would look at, I don't think they're really going to go that far. It is a possible thing. I don't think they would really do that though. So you would look at is you would look at the momentum right before and right after, like immediately after the collision, but they would be slowing down the whole time outside of that. So it's a very fine-tuned thing, but I've never seen a question like that. It's a lot of details. Now, what they could do is have like two things collide on like something like, say, slide down a ramp that's not frictioned and then go across like a patch of friction and then collide into something after. We've done stuff like that, but they tend not to have it colliding on a frictioned surface. That's a lot of extra calculations going into play that I've never seen them do, and I wouldn't envision them doing anything like that. That's a lot of extra.
Then yeah, that's fine for me. Yeah, that's fine.
Okay. Anything else? Any other topics anybody wants me to go over anything about from our entirety of physics that we've done?
Can we do like stress, strain, and
Well, we don't have
Yeah, Young's modello, modulus.
yeah.
Remember I told you for the most part those are just know the formula and apply it.
Okay.
So you have your stress, which is like when you pull something. Your strain, which is where you try to compress something. If I'm pretty sure I got those in the right order. Google just to make sure.
Why did they make the word so similar?
Strain is extension of original length. What is the cross sectional for stress?
It's cross sectional of whatever you're trying to pull.
Does it? Do they usually give it to you?
Well, usually it's like a
Right.
circular wire or something like that, or they'll give you like it's a square or a rectangle or something like that.
Okay.
So let's see.
And then, and then springs is kind of easy. Yeah, it was just strain and stress.
Yeah. So your stress is your force over your area, which I guess you could be pulling or squishing there. And strain is like it's a property of the material basically. It can only take so much strain. It's kind of like obviously I'm assuming somebody at some point has pulled wires, like any kind of wire, yarn, a piece of hair, anything, and you've pulled it hard enough to break it. Strain
yeah.
is the like limiting factor of the material because you can only have so much strain before it breaks.
But doesn't when you like pull like copper, like doesn't it just thin out? And does that have anything different than something that just snaps?
Well, copper will only stretch so much before it breaks. It hits a
So I
limit.
guess like if you
Yeah, every value has its limit of when you pull it. It's just like a spring. Spring, the strain is very easily. It's not deformed. It goes back. So that we would say that that's a returnable strain. Whereas if you take something like a piece of wire and pull it until it snaps, you're deforming it. Or even if you take the spring and pull it so far that it doesn't go back to its original, you're deforming it at that point. And that would you'd be applying a strain to the material at that point. Once you strain it, you're basically changing that material. But yes, what they do to get like thin copper wires and stuff like that is they'll heat them and like pull them until they become really thin. But if you pull them too far, even if they're not heated or whatever, like any kind of wire, if you pull it too far, then it'll break. And in a lot of cases, like most rigid materials, like regular material, like for instance, if you have a piece of pasta at your house, go try to pull it. Well, it's not going to do anything. It's going to break. It doesn't actually stress. It doesn't change the length any. So it's a very rigid material. Other things, such as like if you take a piece of like yarn or string, you'll notice that you can kind of have it tight, but then pull it a little more, it stretches a little bit. That would be your strain type idea there. Till eventually at some point it's going to have enough strain that it's going to break.
all right.
And
Since class is like over, I guess technically, can we tomorrow go over how to find like periods